Partial fraction decomposition. This video will help you decompose a complicated fraction into smaller, simpler fractions. And we use this in calculus when we go to integrate very complicated fractions. That's very difficult to do. So what we do is we use this partial fraction decomposition to break a complicated fraction into smaller, simpler fractions that we can easily integrate. Okay, and we've kind of got four cases here that we're going to be taking a look at. So we've got a fraction here. And we're just representing that as p over q. Now these are going to be polynomials in the numerator and denominator. There are four different cases that we're going to look at with these fractions. The first case is we have distinct linear factors, meaning some sort of factor, something like this. Different than the next one. They have to be linear, meaning that we don't have any x squareds or x cubed or anything like that. Linear meaning we just have to have x to the first power here as our factors, and they all have to be different. That's the first type we're going to take a look at. That's kind of case one. Case two is where we have a repeated linear factors. So we might have something like this, x plus 1, again linear, but this next factor is going to be repeated, meaning we'll have a higher power than 1 on that factor. And so that's a little different situation in terms of our setup for our partial fraction decomposition. Another case now is not a linear factor, but we have a prime quadratic factor. Maybe something like that in the denominator of our factor. Prime meaning we can't factor it. If we could factor it, then we could turn it back into one of these two cases, case 1 or case 2 here. So quadratic factor looks like that's prime. And then the final one is just the same thing with this quadratic factor, but if we have a repeated one. So if we had more than one of those things. So those are kind of the four cases we're going to look at. Distinct linear, linear but maybe something's repeated in there, a prime quadratic, and then a quadratic with a repeated factor. Okay, so we talked about these four cases, and what we're going to have to do in all of these four cases is kind of use a little different setup. Now there's a lot of patterns to these setups, and I think once we go through them you'll be able to see these patterns, and it won't be so difficult to learn this, because these cases you're going to have to learn or memorize these cases so that you can set up the correct decomposition for these fractions. Okay, as we talked about before, case 1, denominator is a product of distinct linear factors. So here is the complicated fraction that we want to decompose. The first thing we need to do is to set that up. So notice I have distinct linear factors here, and so the way we set that up is every one of these factors gets a numerator, kind of a mystery numerator. Notice I've taken the 2x minus 1 and put a over top of it. Then I'll take the next distinct linear factor, x plus 2, and I'll put this mystery value b above that, and then x minus 2, this unknown value c above that. And so what we're going to do is we're going to write each of these factors as a distinct, meaning a separate fraction. So we've got this one simpler fraction plus this next one plus this third one. Notice every factor becomes a denominator in each of my fractions, and that's really all there is to that. However many factors I had down here, that's how many fractions I would have here, and notice they're all just being added. It's possible that sometimes these values up here will be negative, but when we set it up, we just set them all up with addition. So pretty straightforward. Take each of the factors, write it as its own distinct fraction. All right, case 2. Talked about it before. We have now linear factors down here, but one of them is repeated. Notice this guy here is taken to the third power. So what we want to do when we write out this partial fraction decomposition, the first factor, which is distinct all by itself, just x, we write a over top of that. And then for this with a repeated factor, we want to represent each power of this factor. So watch the pattern here. I'm going to first represent that x minus 3 to the first power, gets a b above it. Then I'll represent that x minus 3 to the second power, gets a mystery or unknown value c above that. And then finally, we write it to the third power. So notice, very similar to case 1, where we now have a set of distinct fractions here, We just needed to represent every one of these powers if there's a repeated factor. Okay? Case 3 now. Now we're moving away from linear factors. Now we're getting a quadratic factor here. So notice I've written one of these factors as a linear factor. So that's going to stay exactly what we've been doing. This x minus 3 gets an a above it. And now our quadratic factor here, since we have an x squared and an x, then what I need, instead of just a b or a c up there, I need a bx plus c. And that will work, and that will happen every time when we have a quadratic factor like this. It will always be some value x plus some constant value above it. Now just kind of putting these two ideas together here for case 4 is now we have a repeated quadratic factor. Remember when we had a repeated linear factor, we had to represent that linear factor, each power of that linear factor. Well, we do the same thing down here with a quadratic factor. So if I have this quadratic factor, x squared plus 1, I know it's quadratic because I have a squared in it. To the second power, I need to represent every power of that. So here it is to the first power, and since it is a quadratic, I'll get ax plus b, and then here it is to the second power, and then I will get cx plus d. Notice I want to make sure I change these values, c and d, same format as this first one, but these are different values above this one that's squared. And so that's what we do to set these up. So you're going to want a partial fraction decomposition. You're going to want to examine it a little bit and decide if it's a case 1, case 2, case 3, or case 4, and then set this up. So as you're practicing, make sure you're trying to write these setups off the top of your head. You might mess it up at first, but that's a great way for you to learn how to set these things up, because that is something that you're going to have to know and have memorized. Really not that complicated, but it's something that you're going to have in your memory to do this. Now that we looked how to set these things up, now let's look at the steps that we use to solve them. Some of these steps may not make total sense now, but when we look at an example here, it will. So as discussed, step 1 is just to set it up. So we look at the partial fraction decomposition and figure out which case it is and set it up accordingly. Once we set it up, then we're going to multiply both sides of the equation by the LCD. The reason we're doing that is because it's easier to solve equations that don't have any fractions in them. And anytime I multiply both sides of an equation by the LCD, it clears all the fractions out. So it will do the same thing here. It's going to clear all the fractions out. Once we get the fractions cleared out, then we're going to simplify both sides of the equation. And then we're going to write both sides of the equation in descending order. So we want to get all our highest power terms working all the way down to our lowest power terms. And then what we're going to do is we're going to equate the coefficients of the like terms. And this step 4 right here is a really kind of a very slick or very brilliant move by a mathematician, whoever figured out how to solve these partial fraction decompositions. This step 4, he was pretty proud, or she was pretty proud of herself when that step came about, because it's pretty slick. So I'll show you here in a second what that looks like. But there was a pretty clever solution technique. Once we equate these coefficients, it's pretty easy. What we get then is we get a system of linear equations, and that's why the past 2 days we've been studying linear equations and practicing up on those, because we're going to get a system of linear equations, and we will solve that system of linear equations for a, b, and c, those mystery values. And once we solve for a, b, and c, then we get the partial fraction decomposition. We just simply substitute those values back into our original setup, and it gives us the partial fraction decomposition. Let's take a look at an example now, and we're going to decompose now a case 1. So case 1, we have distinct linear factors. And so here's our problem here. I've said, okay, we want to set up a partial fraction decomposition for this fraction here. And notice 2 different linear factors in the bottom. So all we need to do to set that up is for each factor, give it its own distinct fraction. So we write the first one over under a, and then we write the second one with a b on the top. And again, addition between those two. Step 2 now is we're going to multiply both sides by the least common denominator. So notice here was my setup right here, and I want to multiply both sides by the LCD. Well, as it turns out with these partial fraction decompositions, the least common denominator is always just the denominator of our original starting fraction. So all I'm going to do is take and multiply both sides times x minus 3 and x plus 4. And you can see me doing that right here. So I think it's a good idea maybe to think about this as over 1. And then the same thing on this side, multiplying the right side by that x minus 3, x plus 4. And what that does now is it divides out all these factors for me. Notice the x minus 3 here will divide out with that x minus 3, the x plus 4 with that. Over here on this side, the x minus 3, when I go to multiply here, the x minus 3's will divide out. That's gone, and that's gone. And what I'll have left with is a times this x plus 4 left to multiply. And so you can see that's what I got down here. That's the a times the x plus 4. Now when I go to multiply by my second fraction here, notice the x plus 4 factor is going to divide out before I multiply. So those are gone. And all I have left then to multiply is this b times this x minus 3. And you can see me have that written right there. Okay, so notice multiplying by the LCD takes this complicated fraction setup we had up here, and it really simplifies it down to a nice equation where we don't have any fractions. Okay, now I'm going to simplify both sides of the equation, and what that means here is I'm going to distribute this a and this b. And this step will always be the same. Once we get done multiplying by the LCD, we'll distribute the a, b. If we had a c in here, we distribute that too. So we distribute those values, and notice I get ax plus 4, bx minus 3b. Now what we want to do is we want to organize these guys in descending order. Notice I have some x terms here, and I have just some constant terms here. Remember, a and b are just values. So this is going to be 4 times some value. So this is a constant term, and that's a constant term. And I want to group these things together in descending order. So what I'm going to do here is I'm going to put my x's together. I'll write those guys first. So I'll have ax plus bx, and then I'll have plus 4a minus 3b. Now notice over on my left side, and this will always be the case, this was already written in descending order, so I didn't have to do anything. So now what I want to do is I want to factor an x out of those terms, and that's what I've done right down here. Okay, I factored an x out of each of those. And so you can see now that this equates to the 5x. And this statement, since this is all of my constant values, is going to equate to this -1. And here's the real slick part of this that the mathematician figured out. That once they got here, they got at this step here, this probably took a while to figure out, but they figured out if they organized it correctly like this, then if we look at this, well, if this right side is going to be equal to the left side, then this a plus b has got to be equal to 5, because here is the only part that has any x terms in it. So we know that a plus b is equal to 5, right there. Since these are my only constant terms on the right here, I know that 4a minus 3b is going to have to be equal to -1. For these two sides to be equal, those two things are going to have to happen. And notice what we have now is we have now a system of two equations with two unknowns. We know how to solve a system of two equations with two unknowns. So here's our system. All we're going to do now is use our skills like we always have to solve this system. So I solve this system over here. Looks like I'm removing a and multiplying the top equation by -4 here. So I can drop a out. I drop a out. I come down here. I solve. I know that b is 3. I substitute it back into one of the two equations, and I find out that a is 2. Well, once I figure out what a and b are, I've found my partial fraction decomposition, because remember, this was a right here in my first fraction, and this was b in my second fraction. And so what I've done now is I've taken this more complicated fraction over here, and I've written it now as a simpler two fractions being added together. In fact, if we took and added these fractions together, we would get this exact answer over here. Now we're kind of going in reverse, breaking these things up into simpler added fractions, or simpler fractions that are added together, because now when we get to calculus, we'll be able to integrate those things easily. So it's time to take a look at a practice here, and there's lots of information going on, so we're going to kind of just do it one step at a time here. So our practice 1 is now we're going to decompose a case 2. So we have repeated linear factors. Notice here I have a second power on one of my distinct linear factors. So the first thing you want to do now is pause your video player and let's just set this thing up. So go ahead and set up the original. Go ahead now and set up the original structure of our decomposition. And when you're done, hit play, and then we'll kind of go through step by step here as we go. So hopefully what you recognized here in your decomposition is I have one distinct linear factor, so that will be the denominator of one of my fractions. I'll write that over a. Then I need to represent every power of x minus 1. So I'll write x minus 1 to the first power, and I'll put that under b. And then I need to write x minus 1 to the second power, and I'll put that under c. So now the next step is to multiply both sides by the LCD. So let's go ahead and pause your video player now, and you want to multiply both sides of the equation by the LCD. And remember, I already gave you a hint on this. The LCD is going to be just the denominator of our original starting fraction. So go ahead and multiply both sides by the LCD, divide things out, simplify it down the best you can, and then go ahead and hit play and see how you did. All right, let's see how you did. So I take my LCD, which is just the denominator of the original fraction, and I want to go ahead now and I'm going to multiply it first by the left side of the equation. Notice everything there is going to divide out. This x will divide out with that x, and then x minus 1 squared would divide out with x minus 1 squared, and so all we'll have left on that side is x plus 2. Continuing on now, let's go times the first term on the right side. So let's see, first thing we notice is that the x will divide out here. And so once the x divides out, all I'll have left to multiply then is a times x minus 1 squared. All right. Now when I go to multiply by my second fraction on the right side, notice this x minus 1 will divide out with one of these. Notice I have two of them up there because it's squared, but one of them will divide out. So what I'll have left then is I'll have this b times x minus 1 left for that one. Okay. Then when I go to multiply by my third fraction on the right side, notice my x minus 1 squared will divide out with my x minus 1 squared. So all I have left to multiply by here is just x. So it'll be plus cx. So we've multiplied. Let's kind of review our steps here. We've written our partial fraction decomposition setup. We've multiplied both sides by the LCD. And now what we want to do is we want to simplify this right side. And simplify this right side, all that means is we really just want to multiply this stuff out. Okay? So before we do this step, just a hint here, what you want to do, we would want to take this x minus 1 and square it and see what that is first, and then distribute this x in here. After we get done with that, then we'll go through and multiply by b, go through and multiply by a. So go ahead and pause your video player now and work through these steps. All right, left side is x plus 2. A, let's figure out what x minus 1 squared is. Well, x minus 1 squared is going to be x squared minus 2x plus 1. That's what that looks like. And then here, let's distribute this x, so it'll be b times x squared minus x plus cx. Okay? So continuing to simplify here, I'm just going to distribute my a through and distribute my b through. So let's see, I'll have ax squared minus 2x, minus 2ax plus a. And when I distribute the b, I'll have bx squared minus bx plus cx. Okay? That's as far as we get in terms of simplifying. Now our next step is going to be to organize these things in descending order. Okay, so step 4 is write both sides in descending order and then equate the coefficients of the like terms. So what we're going to do here is get these guys organized in descending order, and then from there we should be able to write a system of equations that have a, b, and c in there. We should have three separate equations when we get done organizing this guy. What you want to do here is you want to organize your x squares together, your x terms together, and make sure that we don't leave anything out, okay? Because notice there are no x squareds over here, but there's x squareds over here. Well, we can write this side, we can think of this as a 0x squared. That's a term. We've done this before with long division. So we have to have a place for every single power of x in order for us to organize this to write our system of equations. So go ahead and pause your video player now and organize this in descending order, and then come up with the equate the like terms to come up with your system of equations. Okay, so we already said 0x squared here plus x plus 2 is equal to, now let's organize our x squared terms first. So ax squared plus bx squared. Let's see, let's go to our x terms next. So notice I have a minus 2ax and a minus bx and a plus cx. And then I just have one single variable there that's going to be the constant part of my equation, just plus a. So let's make sure we've got this. I did. This is a good place to make a mistake. So I used those two guys right there. That's that and that. Then I've got the 2ax and the minus bx and the plus cx, and then finally the a. Kind of helps me to cross those out to make sure I've got everything in its place. Now once we've got it in descending order, we're ready to write our system of equations. Notice I want to factor an x squared out of these first two terms, an x out of the next three, and then that one's going to stand alone by itself. So let's see, if I had an x squared, it would be a plus b if I factored that out. And now if I factor out an x here, I'll have negative 2a minus b plus c, and then finally plus a, equal to 0x squared plus x plus 2. So now we're ready to write our system of equations. Notice, if these two sides are going to be equal, a plus b, my x squared term, is going to have to be equal to this 0x squared. And so that's where that comes from. A plus b is equal to 0. And then for my x terms here, all of this stuff right there is going to have to be equal to 1. Notice I had a 1 there in front, so you can see that there. That's equal to 1. And then just for my constant term, that means a has to be 2. So go ahead now and set up your system of equations to solve this guy. The fact that we know a is equal to 2 makes this a lot easier. I don't think we want to start out with elimination here. I think we want to start out with substitution to solve this. But go ahead and set up your system of equations now and solve for a, b, and c. All right, let's take a look. So here's our system. We know a plus b equals 0. Negative 2a minus b plus c equals 1. And then a equals 2. Well, heck, that makes it super easy. Look, notice a is equal to 2. Let's put that right up here. If I know that's equal to 2, then I could say this statement. 2 plus b is equal to 0. Well, if 2 plus b is equal to 0, then we know that b is equal to negative 2. Hey, I'm almost home now. Let's substitute both of these guys now into this equation to figure out what c is. So I know that negative 2 times the a value, which we already know is 2, minus b, which was negative 2, plus c equals 1. Notice when I substituted this negative value in here, I put it in parentheses. That just makes it so much easier. Anytime you're substituting a value, putting it in parentheses will make it a lot easier to see. All right, let's simplify this guy and figure out what c is. So that's going to be negative 4. This is going to be plus 2. Plus c is equal to 1. Well, negative 4 and positive 2. Negative 2 plus c equals 1. Add 2 to both sides. C is equal to 3. All right. Now that I've solved my system of equations, I'm ready to use those values now to go ahead now and write my partial fraction decomposition. So we know a is 2, b is negative 2, c is 3. All we have to do now is substitute those values into our original equation there, our original setup, to write the partial fraction decomposition. So we know this is going to be 2 over x plus Negative 2. Now here's the thing. We can write the negative 2 up here, or you can just write this as a subtraction sign. I think it's cleaner to write it as subtraction. So since it was negative 2, I'll write minus 2 over x minus 1. C is positive, so then we'll be plus 3 over x minus 1 squared. And there is our partial fraction decomposition of our original fraction, x plus 2 over x times x minus 1 quantity squared. Now that we've kind of walked through one step by step, now it's time to take a look at this and see if we can walk through the whole thing all at once. So we're going to do the partial fraction decomposition of this guy here, and this is a case 3. So we've got a prime quadratic factor in the denominator. So notice I've got a distinct linear and then a prime quadratic down there. So work as much as you can and then go ahead and hit play to see how you did. All right. So here's my setup, first of all. So we're starting right here with the setup. So I said, all right, I've got a distinct linear factor, so I write that over a there. Now I've got this prime quadratic, and remember, when I have the quadratic, I need to write it with a bx over c above it. Once I've got this set up, now I'm going to go ahead and multiply by the least common denominator, and like always, the least common denominator is just the denominator of my original fraction there. So you can see me here multiplying both sides of the equation by x plus 3 and then x squared plus x plus 2. Okay? Now as I go and multiply the left side, you can see that everything is going to divide out. The x plus 3 with the x plus 3, the quadratic with the quadratic, and so all I'm left with there is just the numerator. On the right side, let's kind of follow along and see what happens here. So first factor here, the first fraction I go to multiply by, notice my x plus 3 is going to divide out with my x plus 3. So all I'm going to have left is this a times this quadratic, and you can see me writing that right there, a times that quadratic. Now when I go to multiply by my second fraction, notice the quadratic is going to divide out. Boom, that's gone with that, that's gone with that. So what I have to do now is I have to take bx plus c times this x plus 3. And you can see me right there, bx plus c times x plus 3. Now I want to simplify this side. So let's see, that means just distributing the a here, and then go ahead and foiling these two together here. So this bx plus 3c times this x plus 3. And so here I am distributing the a. So that's going to give me ax squared, ax plus 2a. Then I'm going to go ahead and FOIL these guys. So this is bx squared, and then 3bx, multiply by the c now. So that'll be cx, and then 3c. Once I've got this big mess here, I want to organize it. So I want to get all my power terms together. So notice I'm looking now and saying, well, let's get my x squareds together. So here's one, that's it. And then my x's together. Notice how I'm underlining this with different lines. That helps me organize it. So, and then my constant terms. So 1, 2, 3, 1, 2, 3. Those guys are going together. So here I am now bringing my ax squared and my bx squared together, and I'm going to factor an x squared out of that, and you can see right there that's going to be a plus b times x squared. And then, so those are done. Then let's look at my x terms. I've got an ax, a 3bx, and a cx. So I'm going to factor an x out of all three of those. So that would leave me with a, 3b, and a c. And there's my x factored out of that. So those guys are gone. X's are gone now. Let's see. And then I've just got this 2a plus 3c on the end. Those quantities are going to have to add up to my constant terms on the other side. Now let's look and make sure I've got a spot for each of these. Yep, I've got an x squared here, I've got an x, and I've got a constant. So I don't have any terms missing there, so I don't have to use any zeros. So then I would say, all right, if this is going to be true, then a plus b is going to have to be equal to 8. if this is good, the next one is going to be true, then this a plus 3b plus c is going to have to be equal to 12. So there it is set up to 12. Then these last two terms are going to have to add up to my coefficient over here, which is negative 20. All right, once I get here, now I'm ready to set up my system of three equations. Okay, so here's my system of three equations from before. Let's see, what did I decide to eliminate? So it looks like I'm taking these first two equations and I'm multiplying this top one by negative 3 so that I can drop out the b's here. This is a positive b, that's a positive 3b. So if I take and multiply this top equation by negative 3, it will help me eliminate those b's. So there I did multiply everything through by negative 3, and when I add them, notice I'll get a negative 2a, my b's drop out as planned, and I'm left with a c. So I get this equation negative 2a plus c, because remember again what I'm doing is I'm trying to come up with trying to narrow this down, the system of three equations, narrowing it down to a system of two equations with the same variable. And I noticed that by combining 1 and 2 here, I could get an equation that just had a and c left in it. And if I can get an equation with a and c left in it, notice I got this equation and this equation over here, and now I've got a system of two equations, two unknowns. So now I'm going to go ahead and solve these guys right here. And it looks like now nicely that the a's will drop out if I add these guys just as they're written. So that's what I'm doing here, adding these two equations together. 2a minus 2a is gone, and then 3c plus c is 4c, negative 32. Divide both sides by 4, and I get my first value. C is negative 8. Now all I have to do is take that negative 8 and substitute it up here for C or over here for C. It won't matter. I'll get the same answer. So let's see, what did I do? I said C was equal to negative 8, and it looks like I plugged it into this guy right here. So that's what I'm doing right there. Taking this negative 8, plugging it into that equation. When I plug that negative 8 in there, I go ahead and solve this thing, and I figure out now that a is equal to 2. Once I know a is equal to 2, I already know what a is. Let's take this equation right here to figure out what b is. So there I am substituting a is 2 into that equation there. And then we figure out that b is 6. Once I've got a, b, and c, now I'm ready to go back to my original setup and substitute those values to write my partial fraction decomposition. So a is 2, b is 6, c is negative 8. So I go ahead and plug this guy in there. There was my a value, there was my b value, and there was my c value. Notice, since we have two terms up here, even though c was negative, there's no advantage to writing a subtraction sign here. There was in the last one where I just had one term up here. But if we have more than one term, write addition here and just write the signs on those values. All right, hopefully you got that. All right, let's try a final one here. So, practice question 3, we're going to look at case 4. And remember, case 4 was a repeated quadratic factor. So really not that much different. Remember, with a repeated factor, we have to write a fraction for each power of that factor. So go ahead now and pause your video player and set this thing up, work through and solve it, and when you get done, hit play to see how you did. All right, let's take a look. So if I have a repeated factor, whether it's quadratic or whether it's linear, I got to represent each power. So notice I take x plus 1 to the first power as one of my fractions, and then x plus 2 to the second power for one of my fractions. Since these factors are quadratic, I got to have an ax plus b and then a cx plus d. We want to make sure these are different values. You wouldn't want to use a and b here again. These all have to be very distinct values. So ax plus b and then cx plus d for my next one. Okay? And as before, we want to get rid of these fractions. Fractions in an equation, we don't have to have them. We just multiply by the LCD. Well, the LCD, like always, is just the denominator of my original fraction. So you can see me going through here and multiplying both sides by x squared plus 1 to the second power. So when I go to multiply it here, lo and behold, the whole denominator is going to divide out like it always does, and I'm going to be left with just the numerator. Let's see what happens when I go here. So here, notice I just have an x squared plus 1 to the first power. So one of these guys will divide out, but I'll still have one of these x squared plus 1s to multiply. So I'm taking this x squared plus 1 times this ax plus b. And you can see me doing that right there. Ax plus b times the x plus 1. When I go to multiply by my second fraction, notice this is x squared plus 1 to the second power, x squared plus 1 to the second power. Well, those are going to divide out entirely and leave me with just cx plus d. Once I get here, now I want to simplify this thing and write it in descending order. So that means multiplying all of this stuff together. So I'm just going to go ahead and FOIL this out, distribute the ax, and so I'll get ax. I'm not sure why I wrote this line in there. Just ignore that line. We're going straight from here to the next one. It's kind of redundant there. So let's see. I write ax times x squared is going to give me ax cubed. Ax times 1 is just positive ax. Now I distribute the b, bx squared. B times 1 is b. Then plus this cx and plus this d. Now let's get this thing in descending order. So looks like I've just got 1 cubed, 1 squared, an x term there, an x term there, and some constant terms. So I'll write my ax cubed first, my x squared second, and again, just redundancy here. Ax cubed first, bx squared second, and then ax plus cx for my x terms, and then b plus d for my final constant terms. All right. These are distinct and different, so I don't have to do any factoring there, but I will factor an x out of those two terms. So now let's look. If this is going to be true, ax cubed has got to be equal to 2x cubed. Well, that tells me right off the bat that a is 2. Let's see. I don't have any x squared terms here, so I want to think of this as 0x squared in there. I have a 0x squared in there. So that tells me then, if this is going to be true, bx has to be equal, bx squared has to be equal to 0x squared, which tells me then that b is 0. All right. I know for my x terms that a plus c is going to have to equal 1. That's there, so I write that down. A plus c equals 1, and then b plus d is going to have to be equal to 3. Once I've got that, now I'm ready to set up my system of equations. And so here's my system. A is 2, b is 0, a plus c is 1, b plus d is 3. Well, let's see. I know that a is 2, and I know that a plus c is 1, so I'm substituting a in there. Substituting 2 in there for a. And then subtract 2 from both sides, and I get that c is equal to -1. I already knew that b was equal to 0, so I'm just going to substitute that into this equation right here. So I put a 0 in there for b, and then it looks like d is equal to 3. So this system was actually really quite easy to solve, because the system of 4 equations we had was pretty straightforward. So now that I have my a, b, c, and d values, I can substitute that back into my original decomposition, and I get the partial fraction decomposition of that original fraction.